Hey everybody, today's lesson is about multiplying and dividing rational expressions. Now before we get into the rational expressions themselves, let's start by multiplying fractions since multiplying rational expressions is a whole lot like multiplying fractions. So we'll begin with 2/3 times 5/7. So when you multiply fractions, it's pretty straightforward. You simply multiply the numerators together, so I'm going to take 2 times 5, and you multiply the denominators together, so 3 times 7, which in our case will give us 10 over 21. Since this fraction can't be simplified, that's the end, and that's our solution. For our second example, we'll take a look at 4/5 times 15/2. So before we even multiply, we can actually simplify. So 4/5 can't be simplified, and neither can 15/2. However, we can also simplify diagonally. See, 4 is 2 times 2, and which means that we have a common factor diagonally. So we can cancel out the 2's here. And 15 is 3 times 5, so we can cancel out the factors of 5, leaving us with 2 times 3 in our numerator over, we cancel out both of our denominators, so it's really just 1. So 2 times 3 divided by 1 is 6. Alright, so now let's try a problem that's a little bit more fun. So the first thing that you want to do when multiplying rational expressions is factor. That way you can see if you can cancel out any common factors, as well as finding your excluded values. So let's start with the first fraction here. So my numerator, I can factor out a 5, and we would be left with 8x minus 9 in our numerator. Denominator, a 6 can be factored out, and we're left with x minus 3. Now let's factor the second fraction. So our numerator has a common factor of 3 that we'll factor out, leaving us with x minus 3. And our denominator has no common factors, so it'll be left as 8x minus 9. Now, as always, before we start canceling out common factors, we should find our excluded values. So let's take our denominators, or at least the parts with variables, and make sure that we don't have anything that will give us an undefined value. So x minus 3, that factor in our denominator, cannot equal to 0, so x cannot equal to positive 3. And 8x minus 9 cannot equal to 0, so x cannot equal to 9/8. So now that we have our excluded values listed, let's cancel out any common factors that we might have. So let's start off with the obvious. Here I have 8x minus 9 and 8x minus 9 that can be canceled out, as well as x minus 3 and x minus 3. I also see that I have a coefficient of 3 here, and in the denominator I have a 6, which is really 3 times 2, so a 3 can be canceled out. So our final solution is just a 5 in our numerator and a 2 in the denominator, or 5/2. Alright, on to the next example. So for our first fraction, we'll factor the numerator, which will be x minus 3 times x plus 2. Denominator stays x minus 1. Times, the numerator, the second one, stays x plus 3. And we can factor out a 4, leaving us with x plus 2. Now, from here, we can list our excluded values. X cannot equal to positive 1 or negative 2. And now let's go ahead and cancel out our common factors, which in this case is only x plus 2. So this leaves us with x minus 3 times x plus 3 over 4 times x minus 1. Now, you can leave it like this in factored form, or you can go ahead and multiply through, which in this case would leave you with x squared minus 9 over 4x minus 4. Alright, we'll stick to our factoring for our third example. So, in this case, let's factor our numerator from the first. And this one will take a little bit more effort, but it will factor to 2x plus 1 times 2x minus 7. The denominator will factor to 5 times x plus 1. Our second fraction will factor to x plus 1 over, and you got to watch out for those difference of square problems here. In this case, we'll have 2x plus 7 times 2x minus 7. Now we can go ahead and take care of our excluded values. In this case, x cannot equal to negative 1 from our first denominator, and negative 7 over 2, as well as positive 7 over 2 from our second fraction. Now let's go ahead and cancel out our common factors here. So 2x minus 7 and 2x minus 7 will cancel out, as well as x plus 1 and x plus 1, leaving us with just 2x plus 1 in our numerator over 5 times 2x plus 7 in our denominator. Now, I'll take this moment to remind you guys not to be fooled in trying to cancel out the 2x and the 2x. Remember, you cancel out common factors, not common terms. So in our case, we can leave it like this in factored form, or we can distribute our denominator here to get giving us 2x plus 1 over 10x plus 35. Now let's move on to some division. So to divide fractions, we need to remember one very important thing, and that's KCF, keep, change, flip. What this means, and we'll use our first example here as a guide, 2/5 divided by 3/7, is that we keep the first fraction as is, so we're going to keep it as 2/5. We're going to change our operation from division to multiplication, and we're going to flip our second fraction, which means really finding the reciprocal, which is 7/3 in this case. And we're just going to multiply as normal, so we multiply straight across, giving us 14/15. We'll do the same type of thing for our second example here. 3/2 divided by 1/4. So we will keep our first fraction, 3/2. And another way of thinking about keep, change, flip is simply to multiply by the reciprocal of the second fraction here. So now we have 3/2 times 4/1. And since 4 can be factored as 2 times 2, a 2 can be canceled, leaving us with 3 times 2 in our numerator, so 6, over just 1 in our denominator, so just 6. Alright, now let's try one with the rational expression. So, same thing as before, let's start by factoring. So our first fraction can be factored, x plus 2 times x plus 1 over x plus 3. And we're going to be dividing that by 3 times x plus 2 over x minus 3. So right off the bat, we know that x cannot equal to -3 or +3. So now we're going to go ahead and keep, change, flip. So we're going to keep our first fraction, x plus 2 times x plus 1 over x plus 3. We're going to multiply by the reciprocal of the second fraction, which is going to be x minus 3 over 3 times x plus 2. Meaning that we actually now have a new excluded value. Since x plus 2 is now in the denominator, -2 is now an excluded value as well. So now we can do what we usually do and cancel out common factors. So x plus 2's can be canceled out. leaving us with x plus 1 times x minus 3 over 3 times x plus 3, which is the factored form, and we can multiply everything out, and we would get x squared minus 2x minus 3 over 3x plus 9. Here we go with example number 5 now. So our first fraction can be factored, now we have a difference of squares in our numerator, so we're going to get 3x plus 5 times 3x minus 5. And our denominator. Alright, so on to our next division example. In this problem, our first numerator is a difference of squares, which can be factored as 3x plus 5 times 3x minus 5 over our denominator, which can be factored as 2x plus 7 times x minus 2. Our second fraction can be factored. Well, our numerator is going to stay 3x plus 5. Our denominator of 5 can be factored out, leaving us with x minus 2. Now our excluded values are going to be negative 7 halves, positive 2, and that's about it so far. So let's go ahead and keep change flip, where we will multiply by the reciprocal, which is going to be 5 times x minus 2 over 3x plus 5. Since 3x plus 5 is a new denominator, we will also list negative 5/3 as another excluded value. So now let's go ahead and cancel out any common factors we have. Start off with 3x plus 5 and x minus 2, giving us 5 times 3x minus 5 in our numerator over 2x plus 7 in our denominator, which we can expand to 15x minus 25 over 2x minus 7. In this next example, we actually have to contend with 3 fractions here and 2 operations, multiplication and division. So for the time being, I'm going to eschew the excluded values and just worry about the simplification here and multiplying and dividing. So let's start off as always by factoring. So 6x over our factored denominator will be x minus 4 times x plus 1. Our second fraction, we have a difference of squares in our numerator, x plus 1 times x minus 1, and we can factor out an x from our denominator, leaving us with x minus 5. We'll be dividing by, or really when we divide we're multiplying by the reciprocal, so we'll be multiplying by x minus 4 over x minus 1. So now let's go ahead and cancel out all of our common factors. So in this case, let's start off with our first term here, 6x. We also have another single x here, so we'll cancel out the 2 x's. Moving on to the next one, I have x plus 1 and an x plus 1 in the denominator. I have an x minus 1 and an x minus 1. And an x minus 4 and an x minus 4 here. Almost everything cancels out. In our numerator, we're left with just 6, and our denominator is just x minus 5. So long as you follow all the rules that we've laid out so far, multiplying and dividing multiple fractions should not be a problem. For our final example, we'll be looking at what we like to call a complex fraction. We call it a complex fraction because it's basically a fraction made up of other fractions. However, when it's a simple one like this, simple being a relative term, we can think of it as just really another division problem. So I want you guys to see this u minus 6 over 2u over u squared minus 36 over 4u cubed really is just a division of two fractions. So since it's really just a division problem, we'll solve it just like we normally would by keep, change, flip, or multiplying by the reciprocal. We'll keep our first fraction, u minus 6 over 2u. We will change to multiplication and flip our second fraction for u cubed over u squared minus 36. Now, let's go ahead and factor. Really, the only thing that needs factoring is our second denominator, so we'll keep u minus 6 over 2u times 4u cubed over our, now here we have a difference of squares, so we'll have u plus 6 times u minus 6. Now let's go ahead and cancel out our common terms. So u minus 6 cancels out u minus 6. 4 divided by 2 just leaves us with 2. U cubed divided by u is u squared. And so we're left with our simplified fraction of 2u squared over u plus 6. And there we have it on our lesson on multiplying and dividing rational expressions. Hope this helps. I will see you all next time.